Hello, my name is Nazar Ponochevnyi. It is an honor to present our work to you today. Recent chart authoring systems such as Amazon Q and QuickSight and Copilot for Power BI demonstrate an emergent focus on supporting natural language input to share meaningful insights from data through chart creation. Currently, chart authoring systems tend to integrate voice input capabilities by relying on speech-to-text transcription, processing spoken and typed input similarly. However, cross-modality input comparisons in other interaction domains suggest that the structure of spoken and typed-in interactions could notably differ. Thus, in this work, we compare spoken and typed instructions for chart creation. We conducted a user study with 25 participants who created charts using free-form voice instructions. Then, we did a thematic analysis of the collected instructions. Finally, we applied the developed coding scheme to 200 text instructions from the NLV corpus and 200 synthetic text instructions from the NV bench, assessing its fitness. We provided participants with 4 diverse scenarios that included some statistical information and asked them to instruct an imaginary virtual agent to create a chart representing each scenario's information. Through a qualitative analysis of the collected instructions, we identified 6 input strategies, for example, commands and questions, and 22 common elements, categorized into 5 types: chart elements, element characteristics, element organization, format of command, and linguistic features. In the figure, we see the number of times each element of the 5 major types was applied to each input strategy in voice chart authoring instructions. Comparing it with text instructions from the NLV corpus and synthetic text instructions from the NV bench, we found that while both text and voice instructions often cover the basic chart elements and element organization, voice descriptions have a variety of command formats, element characteristics, and complex linguistic features. Our findings on the differences in how people express chart authoring instructions in text and voice surface the need for independent processing of spoken and typed prompts. Voice-based systems should be able to effectively parse and interpret unique linguistic structures and recognize and perform on various command formats. For example, recognizing commands embedded within longer sentences, or interpreting instructions where a user refers to previously mentioned elements. Voice chart authoring systems should also support contextual understanding and feedback. This could involve clarifying questions from the system when instructions are ambiguous, or advising on chart design when users struggle. Our voice dataset can aid in extending existing evaluation protocols like Helm and Superglue to reflect the complexities of spoken chart authoring instructions more accurately. This will enable researchers to design scenarios resembling real-world applications, ensuring a comprehensive assessment of diverse user input styles.